All right, guys, number 14, we are going to calculate the pH at 25 degrees Celsius of a 0.25 molar aqueous solution of phosphoric acid. And it gives you the 3 Ka values. Holy moly. Well, phosphoric acid, H3PO4. All right, well, let's dive in. All right, so you have H3PO4 plus water. And we're going to get, of course, H3O plus and H2PO4 minus. Ice table. And so we have 0.25 molar to start with. Oh, sorry about that. 0.25 molar. None and none. Minus X. Plus X, and plus X is the change. So 0.25 minus X. X and X. Our Ka1 expression. Hydronium. Dihydrogen phosphate. Phosphoric acid. All right, so what do we have here? 7.5 times 10 to the minus third equals X squared over 0.25 minus X. Can we approximate? No. So we have 7.5 times 10 to the minus third times 0.25 minus X equals X squared. Expand, so 7.5 times 10 to the negative third times 0.25. I get 1.88 times 10 to the negative third minus 7.5 times 10 to the negative third X equals X squared. So X squared plus 7.5 times 10 to the minus 3x minus 1.88 or 1.9. We should probably do 1.9 times 10 to the negative third equals 0. Because I only have 2 sig figs. So we're going to erase that and put a 9 there. So x should equal, if we do our quadratic, I'm getting 0.04. All right. So now, if we look at Ka2, it's negative 8. It's a million times smaller. So it's not going to really do anything, right? We can ignore Ka2 and Ka3. So that means that's concentration of H3O plus. So the pH is just a negative log concentration of H3O plus. So the pH is negative log of 0.040. I get 1.40. Now, the reason we ignored, I'm going to write this down, we ignore concentration H3O plus from Ka2 and Ka3 due to them being much, much smaller than Ka1, right? That's why we would do that. Well, if you have any questions, feel free to reach out. I have a question for you. If you do this the way we did it with 2 sig figs, right? What we can do with this is that we can actually do something. I want to teach you something right now in this problem. So that would be good enough for me. But what happens is we can plug this back in. All right? What do I mean by that? We can plug it back in and see if it works. So 7.5 times 10 to the minus third equals x squared all over 0.25 minus 0.04. And let's solve for x squared now. So if we do that, 7.3 times 10 to the negative third times the difference between 0.25 minus 0.04, right? And you take the square root of that, I get 0.039 for x. And so what's going to happen, we can do these things called iterations, where we redo this and redo this a couple times, right? Because that's 400. You could do the same thing again. And I keep getting x to 2 sig figs, x equals 0.039. Which, does that change the pH much? I don't think so. 1.41. So it's not much. All right. So if they ever ask you to do iterations, that's what they're talking about. But I'm not going to ask you to do that. I mean, the difference between 0.14 and 0.14 and 1.40 and 1.41, no difference. So hopefully that helps. Hopefully I didn't confuse you at the end. But I would, for most of you guys, stopping right here is perfect. All right. If you have any questions, reach out. Otherwise, we'll see you the next time.